Hi, I'm here with Andy Ted from Tektronix, and they just hand carried this bad boy over. We're filming this in April. It doesn't get released until June.
June, yep.
June, okay, so you'll be seeing this in June. And you are the...
I'm the business manager in our entry scopes division.
Yep.
But formerly engineer, double E by training most of my career.
Excellent.
So, yeah,
and you were just
engineer.
formerly Voltec. I've got one of the Voltec My Power Analyzer.
I had 18 and a half years at Voltec and great years, and then had the opportunity to move to a different place. And so I've been at Tektronix for 9 years now.
Fantastic. And so where did the creation of this, because we've done a link in and, my first impressions video, because I had no idea, they deliberately didn't tell me what this bad boy was, but it is a battery-powered, optionally battery-powered new 2 series oscilloscope, and it's a different architecture from the 3 series and the 5
That's
series
right.
and whatnot.
This is a brand new architecture, first in the platform for a 2 series scope.
Right. So tell us the genesis, and you started development of this.
We started
the pandemic.
Yeah,
almost.
just before, end of 2019.
Yep.
We were looking at doing what are we going to do next. We've been 5 years ago we introduced our 5 series scope, and since then we've done our 4 series, 3 series, and our 6 series scope. So we're looking at how do we expand down into the 2 series space.
Right.
And we started looking around and saying, what do customers really need in this space? And it's going to help us differentiate and help our customers solve their actual problems that they're dealing with on a day-to-day basis.
You were giving me an example before about the automotive thing with the car. Tell us about that one.
Yeah, so we talked to a lot of customers, and we had one customer who develops ECUs, engine control units, and he has one scope for on his bench, and he has another scope for going into the car. 2 different scopes, 2 different setups, and so when he's in the car, you can't run the scope from the car because the car is the unit under test. You can't load the unit under test, and you want consistency of results. And he was always questioning the results that he got in the car, saying, is that really the same? My setup's different, and so on.
The scope's different. You're using like a handheld portable scope, and
maybe not get the same resolution, maybe not get the same noise performance, the same speed. All these questions crop in, and all this doubt starts to come in as they are actually doing their field testing over their bench testing. And
that was one of the triggers for the choosing this form factor, because I would imagine, how long did it take to figure out the actual form factor? Because the stand is really nice too, as you'll see, and it's different. You can use it sloped like that, or you can use it vertically, which were different screw positions, and you can also have it flat that if you're looking down on your bench, or it's on the floor, or it's on a stand next to you, or something like all these different usage scenarios you've designed into the stand. So
what we found is flexibility is key.
Right.
Not everybody wants just a standard scope sitting on the bench. More and more, there's with the IoT, automotive, there's a need to go out into the field and really replicate your testing. Right. So it's what do people want? It's bench space is a premium.
Yep.
So we found that talking to customers, we did some initial models, and literally the first models that we showed this customer were made of cardboard.
Right.
So we were doing cardboard models.
Cardboard models.
Do you like this? We talk to students. Do you want to do students who are obviously a big user of some of our entry level scopes, and they progress from here up to the 4, 5, and 6 series, and we found that they've been using they were born with tablets in their hand.
Yes, exactly.
And they still today, first year grad students, we talked to them. They said, "No, we need knobs and buttons."
I have hope for the future. That really surprised me. I thought I would have bet that they would want. No, I want a tablet form factor.
You talk to people and say, "Oh, do what Apple does." And that works for a phone.
Yeah.
But this isn't a phone; it's a scope. We've got the touch performance, but we've kept the knobs and the buttons, as you can see here. Nice and simple.
Yep.
We talk to students. Which ones do you use?
Yep.
And all of our designers, we talk to them. There's a lot of buttons on a scope. Sometimes it's a bit overload.
Yeah, it's too many. Because there is free space here. You could have put more on there. Yep. But you've deliberately converted some of them into soft buttons on the front.
So again, we introduced our 5 series scope, and it has a very successful, easy to intuitive to use user interface, and we really wanted to get that down into this space. So we spent a lot of time. How do we iterate and get that down into this space?
And you've got like other features like, you know, that you've really thought of, like grips on the, you know, so when you're holding it like that, your fingers naturally go into those sorts of grips. You've got dual hot swappable batteries, which you were saying were under the airline limit, so that then you can transport, you know, you've even put thought into that.
Yeah, you can put one battery in here, meets the airline transportation limits. You know, we get 8 hours running on this. But what we found was, you know, not everybody wants a battery scope.
Yes,
so
of course.
What we've done is we've made this battery
It just pulls off with a back connector.
They don't. It's a purchase after. You know, you can purchase it with the scope or later. If you don't want the feature, you know, not everybody's going to want a battery. They don't want the weight, the bulk. They just don't need it.
Yep.
And so we put a lot of thought into providing customers with what they want and making sure we don't just pack a scope full of parts and costs and ideas that they don't want, because that creates complexity.
Yes, exactly. And you've got an optional, this is a 3D printed rubber, but we will get to the final one, which will be injection molded rubber, and that converts it into a rubber baby buggy bumper, you know, ruggedized, more ruggedized version.
We're using a lot of the available 3D printing tools these days, including for the rubber. You know, that's a prototype.
And this is 3D.
This is very delicate.
3D printed, so this will not be the final version.
Nope.
So this is just a. This is not a prototype. This is like a short run.
This is what we call a qualification build. So this is where we build a significant number of scopes, and then we split them among various different groups within the company after running them through our calibration process to gather statistical data. We've got a pile of these, and I mean a pile because we literally drop them.
I was going to ask about the environmental testing, job test, vibration testing.
We go through all of it. We've got, you know, back in our facilities in Beaverton.
I was going to say that's in-house?
Yeah, that's all done in-house. Oh, no, we've got about 6 or 7 temperature chambers.
Yep.
We do atmospherics, you know, taking it up into high atmosphere. Altitude. We do, you know, 0 degree testing, which is what is, you know, 0 to 50, which is where it's tested. But then we take it beyond.
Yeah, of course.
We've got shock and vibration tables. And for anybody that's been involved in product design,
I've done videos on that. It's
watching your baby go through that.
It's pretty painful.
It's painful, but it's you know, take a scope and we topple it over. Drop. You know, we've got a very hard concrete floor. And we drop the scopes on all the different surfaces.
Nice.
So it's.
Standard bench height. You have a standard bench. Okay, can it survive a bench fall?
Exactly. We put it through the ringer. And so there's scopes to go for that. We have, there's a room in one of our buildings that's probably 20 scopes, and all they're doing is running night after night, day after day, software quality.
Okay. Right.
No, this is software quality.
This is software quality. Okay.
So we have, this is...
Make sure they don't lock up over time. And
we run them through what we call a stress test, where they get bombarded with all the different PI commands, and just night after night after night, making sure they don't lock up.
Wow.
And then we run through it. You know, it's just the testing is endless. But then we also have, every so often during our program, we do what we call expert user testing. You know, a machine's great, computers are great for doing testing,
but
we get
humans.
We get real. You know, we find every hardware engineer we can in the building and say, "Go, have a go. Tell us." You do not have to fix the problem. You just need to tell us about it.
Just tell us. Do you have a 5-year-old test? I've given my oscilloscope to, I've got a video of my 5-year-old, a 4-year-old at the time, using the oscilloscope, and it's like he got it into modes I didn't think were humanly possible.
I think it's about a 7 or 8-year-old test. We have a colleague in our office in the UK who regularly takes them home, and his kids play with them all the time. So,
excellent.
It is a good test.
It's amazing what they can do.
Yes.
They just, you know, push, you know, because us engineers, we know we're conditioned to do things a certain way. Just, you know, we're biased that way. And you don't want to give it to an engineer to test because, you know, they often won't find they'll find some things, but they'll often overlook.
Well, there's 2 reasons. One is, as you say, is we all do things the same way. So you want to try and get it into hands of people that do it differently,
or who have no idea what the product is.
Exactly. The other thing is, you know, we want to make sure that these users, they really know what they're looking for as well. So that's why we have this expert user testing.
Got it. Now, form factor wise, because it is that thin. Now, first of all, this actually does have a fan in it.
Correct.
Which is temperature controlled, so
Correct.
you can't basically. No, I can barely hear that going. And did you think about making it? Was that a result of, oh no, we have to have that, or was there an attempt made to make it completely passive thermally?
When we started out, we kept that as an option,
Right.
and what we did, it looks like a spaghetti. There's so many thermocouples inside this box.
Right.
Running because we want to look for all the different hotspots.
Yep.
And we found that, to be on the safe side, remember this has to run up to 50 degrees Celsius.
Yes, of course.
So we want to make sure we get the airflow. The last thing we want to do is have any overheating.
So you probably could have done it at ambient lab temperature like here, 22, but if you have to run it at 50,
Exactly.
you probably couldn't get away with it.
And that's why you can't. The fan probably is running right now. It'll be spinning slowly.
Yep.
But it's very much temperature controlled.
Right, and you probably would have ended up with like an alloy backed case, like a more passive, like heat sink, a bit large thermal.
And there is
heat
some
stuff.
heat sinking in there.
Okay.
And we use the case, as you rightly say, for heat sinking in there.
Got it. But this is a plastic backed case,
Plastic
so
backed
you
case,
can't. Unfortunately, you can't use it as.
That's right.
Yep.
And there isn't really much. There is a structural inner metal plate.
Right.
We use that for heat sinking and also for shielding where we need shielding as well.
Got it. And why did you decide on the Tactile? This will be controversial, I'm sure. Some people will hate it. Some people will love it. The Tactile dome buttons, the
Couple of reasons.
membrane front panel.
Couple of reasons. One is again as you mentioned, the single board design.
Yep.
When you have buttons, you've got to allow for travel.
There's travel.
And then you're allowing for that, plus the rotary encoders.
Yes.
And the mechanical stack up of that becomes very tricky.
Got it.
And any other product where we've done that is multiple boards.
Oh, okay.
So
so you physically don't have a front panel board for this?
No, the rotary encoders go onto the main board.
Yeah.
And the front panel here, this membrane is all just a single membrane assembly.
Oh, okay. Right. So it's on the plastic, so
Exactly.
it's adhesively tied to the plastic front, and then you've just got the membrane coming out.
The second reason is this is a portable product.
Yep.
So as you go out into the environment, greasy hands.
Yeah, exactly.
Some of these rubberized, they actually attract the dirt.
Yes.
The dirt can also get down into the gap.
Yep.
So this way, this is easy to clean off. And then,
Got it.
this is, as an added bonus, people are much more sensitive about cleaning their instruments now after COVID. So it does make it easier to wipe
of course,
it down.
because this was developed during the COVID thing, so all that mentally plays into it. You probably wouldn't have even thought about that before, right?
But it's a combination. It's a combination of factors that went into that.
Right. Okay. Wow.
But as you mentioned, COVID. This whole product was
developed. So this was 2 years from go to woe.
Yep. We started in late 2019.
Yep.
And we managed to get out to do some customer visits. A lot of working with intern students for the educational view, working with outside customers, and then March 2020, we all know the world shut down.
Yeah, exactly.
So we had to pivot. We had to work out how are we going to get feedback, but in a more virtual environment.
Right.
So we would do conference calls, Microsoft Teams, that sort of thing. We also, as things eased up a little bit, we were meeting potential customers, in their parking lot of their offices.
No. Oh no.
The car was open, the trunk, and we were doing. But this is all about. You've got to get that customer feedback.
Yeah.
And how else do you get it other than touch and feel?
Yes. Yeah. Exactly.
So we were doing face masks in the boot of a car.
Oh, that's great.
So it's really, and the team just kept iterating.
Right.
We would have our engineering team. We had some very, very dedicated hardware engineers that were in all the time.
Yep.
They were still going into the office as essential workers.
Right.
And then the software team they did an amazing job working from home. And we would literally have, all these different stations racked up, all controlled. We were having to learn how to control things remotely, update remotely. And we would have cameras that you could turn and point at individual instruments, so you could really see what was going on.
Wow.
So our lab became this kind of virtual environment.
Wow, that's fantastic.
So they did a great, the engineering team, mechanical, hardware, software, and then all the ancillary. It's phenomenal to do this during a pandemic, because our offices in the US are only starting to open up in the last few months.
Yep.
On a more regular basis.
Yeah.
So it's been a big
with
change.
everyone almost. Yeah. Wow. And you mentioned that this is a new sort of platform. It's not just going to be this scope.
No.
Maybe you've got other things in mind for this sort of functionality with
Exactly.
the portable tablet. And this has firmware, this has software, what's the word, because I'm not a software guy.
Yeah.
This has software platform compatibility
Yes.
with all the other higher end series. So
Yeah.
if you make a change in the higher end, it flows down
That's
to
right.
here and vice versa.
So this runs the exact same software platform as our
Yep.
4, 5, and 6 series scopes.
Yep.
So, as we have a dedicated team that does new releases on that every 3 months. We call them boxcars, like a train. It just
Yep.
keeps on
Yes.
going, keeps on
Right.
jumping.
Okay. Yeah.
And it's been very successful. If customers come to us and say, there's this feature, and we hear this from a number of customers, and we can then look at that and say, we're hearing this across the platforms. Let's get that feature in. But in the past, it was one scope, one modular scope. You then have to find the engineering team to work on that. Now, because it's a uniform platform,
Yep.
it makes it a lot easier for us to roll out features to all of our customers, not just one segment or another.
Got it. And that's a Linux based. It's based on a Linux.
Well, actually, this runs on Linux.
Yeah.
Our underlying code base has been designed from the ground up to
Yep.
run on both Windows and Linux.
Oh, okay.
So on our 5 series up and up scopes, you can actually buy a Windows option or a Linux option.
Oh, really?
And
Okay.
you can boot it
Right,
either way.
for those customers who might want to run Windows apps on there as well.
Things like MATLAB and
Right,
those kind
okay,
of users, yes.
right.
So they can
Okay.
run. We've spent. This goes probably back 10 years. We've made a decision to rebuild all of the code from literally one line of code at a time,
Right.
up to create this environment that can be flexible for both Windows and Linux.
Got it. And
Because customers that have different needs.
yep, absolutely. What about the the hardware side of things? This doesn't have the same low noise front end as the the MDO3 series.
That's right.
Purely because you wouldn't have it in
Yep.
such a lower cost instrument like this.
right.
Can you tell us about the ASIC development for this? How many ASICs and in what locations
The main ASIC that's in here is what we call our Tektronix ASIC, which is our front end amplifier. That's it.
Oh, okay, right. Okay, right.
So
So,
the rest is
and the off-the-shelf analog digital converter, off-the-shelf ADC, off-the-shelf
FPGA
FPGA
with an SoC.
processor.
Yep.
Okay, right.
Yep.
And do the firmware updates update the FPGAs as well?
Everything.
Right.
Yep.
Okay.
One firmware update, download it from the web, and
Got it.
you're up and running in 5 minutes.
Nice.
Yep.
What sort of functionality did you put in the FPGAs? Is that like the sampling front end and?
We take the samples, so the raw samples go into the FPGA,
Yep.
and from there all the downsampling, triggering's built in there, all the
Okay,
bus
right.
decode's built into there.
Oh, okay. So
it's all in that
FPGA
FPGA.
bus decoding, so which makes it faster, obviously, than doing it in the application. So you sort of separate all the hardware stuff is
Yep.
done in the FPGA.
It's a mixture of the two.
Yep.
So I can't remember exactly where the boundary is.
Yep.
But there's some of it's done in the hardware, and then some of it, the visualization, is more done in the software side.
Right, got it. The decision to make this 500 megahertz, is that because there's because it's portable? If it wasn't portable, would you have gone for the 500
We would have
meg
made
as well?
We would have probably still gone up to 500. There is a need. What we found is people want consistency of platform, so they can use the same scope. So we can extend this up to 500. Where people are going to use this at 500 is there's really nothing out there that's going to give you that 500 with the portability.
Got it.
So we have, I think it's 5 different bandwidths: 70, 100, 200,
Yep.
350, and 500.
500, all
So
software upgradable.
All software
Yep.
upgradable. All the units, it's just easy to upgrade in the field.
And this is not, there's some features that are not going to launch with it, like the digital
That's
logic.
right.
The hardware's built in, it's going to be calibrated, it's going to be ready to go, but is that just for you want to get it to market quicker?
We want to get it to market.
Okay.
So we want to get it to market. We want to get it to market right. We would rather get the features right and get them to market rather than rush them and then be fixing bugs. That's not what we do.
So it's a bit of a trade-off. You want to hold it. You don't want to hold it back forever until every feature is
That's right.
done. Right.
So for the two main features that fall into that category are our MSO on the side and our digital pattern generator.
Pattern gen.
But the hardware is in there. The hardware is tested and the hardware is calibrated.
Right.
So all it requires is an updated firmware license
Yep.
and then the decision of whether to purchase that feature.
Got it. Although there is some inherent risk in that. You could, there could be something going wrong. But I guess you guys have tested it internally. You're just not 100% ready to go to market with it yet.
Well, what it comes down to, for example, on the digital side, you've got the digital signals come in, they go through a threshold detection, they come into the FPGA. We can test all the timing of that. It's the visualization on the screen. So we can test all of that. As part of our calibration process, but it's just that last visualization section.
Visualization hurdle.
It's the UI more than the actual hardware.
Well, the UI for mixed signal scopes is not that easy to do. You've got so many options and different ways to do it. Is it going to separate the screen, or can you overlay them?
You can have them in different segments, then you can combine them all into a bus, or expand them out into individual channels.
Got it.
And you can do that with. You don't just do that with the digital. You can do that with the analog channels as well. So you can actually display your analog channels as a bus decode, for example.
Got it. Oh, one thing I didn't look at. No, there's no probe detection. There's no ×10 auto probe detection on this. Is that this is common on other manufacturers? Is that like a cost thing?
It comes down to the single board design.
Okay. Yes, of course.
Getting the stack up between that pin and then the next layer of boards down, and then that ripples through onto the encoders.
The design. I know how it ripples through.
And so the scope. What ships with 10x probes, default mode is 10x. So you don't have to, when you power up the scope, you don't have to think about it. 10x mode is default.
So the ship probes wouldn't even have the pin on it?
No, they're standard. These ones are standard 10x.
Oh, right. Fixed ×10. Right.
Same as our TBS 2000, for example.
Right.
That has the VPI interface, but that's a separate area.
Yep. Got it. How long were you using, we were talking about this yesterday, I think. How long were you using that original 2.5K tech chipset for?
I think we started that in the late 90s, if I remember right. Almost about the same time I started in engineering.
That started with the TDS 200 series,
that's correct,
right?
Yeah, TDS 200.
And you were using that right up until when did you?
We discontinued the TDS 2000.
Which was still using the same chip.
Still using that same chip.
The C version.
In 2020, I think it was.
Wow, that's got to be 25 years.
Yep. And I think, if I remember right, I think it's using the TPS 2000, and that we discontinued last year.
Oh, okay. So
yes, it's
wow.
It's been a great chip though.
I know.
Yes, it's got the limited memory.
Well, it was groundbreaking. Back when I've got one down there. I took it through the mud and it still works. I've got a video where I took it through the mud. Yeah, and that was groundbreaking.
Yep.
Like that was the first real time scope, as in like 10 times the sample rate was 10 times the bandwidth.
Right.
Like the rest of them were 20 meg samples per second. They had the equivalent time sampling, which didn't make it a real scope.
Yes.
Like it didn't make it an analog replacement. That was the first analog replacement.
Our TDS 2000, 3000, they're everywhere.
Yep.
They're still out in the field and they just keep running.
Yep.
They're great scopes, but people move on, time needs move on.
Exactly. So what does this replace? Does this replace a
fundamentally the main focus is our MSO and DPO 2000 series scope. That's what this is going to be replacing.
Okay, so there's no more DPO.
The DPO we're now running. That's running down now.
Right.
We're still making the MSO 2000 for a while, but this is the direct equivalent of those.
Got it.
We've still got our TBS 2000, which has a unique play in having the VPI probes on the front end of that.
Okay.
So that allows you to plug in, for example, our current probe.
Right.
Auto-powered, auto-detected, just up and running. So for doing power measurements, TBS 2000 again is just an awesome product.
That's designed for the educational market, though, primarily, right? Is it? Or?
No, we find that in people doing power measurements, education measurement.
Right.
It's just a sort of one step up from maybe our 1 series scope. It gives you that more features, capability.
Right. Do you guys make a dedicated power oscilloscope?
No, we used to make the TPS 2000, which was an isolated scope.
Yes, right.
But we don't make a dedicated power scope.
Right. Does anyone make a dedicated power scope anymore?
The only one that I'm aware of, I think Yokogawa made one. They do that kind of scope. It's like it's a isolated multi-channel scope.
Right.
But these days, you're on our 4, 5, and 6 series, we now have a lot of power applications. You can do phasor diagrams on a scope now.
Yeah.
So
yeah,
it's amazing what you can get in there now.
Yep.
So the scope that blends between power and just a regular scope is the differentiation is shrinking.
Got it. So there was no thought about putting the spectrum analyzer into this, like the MDO3, because you didn't want to compete with the 3. It would have.
It's
not that.
Again, it's putting hardware into a product that hardware costs money. Hardware costs time to develop.
Yep.
And we've got our 3 series, which is great. Having that mixed domain, dedicated analog input, RF input, giving you that really nice, really low noise floor.
Got it. And a 4-channel, obviously, there's no 2-channel.
No, there is a 2-channel version.
There is a 2-channel. Physically 2 channels. You actually remove the hardware.
Physically 2 channels.
Okay.
So it's 2 channels plus the aux.
It's the same board. You just wouldn't populate the parts.
That's correct.
Right?
Yep.
And change
so
the
depopulation.
plastic. Yep.
No,
no, you'd probably have the same plastic. You'd probably just go over it.
Yeah, there's punch outs in the plastic.
Yeah, right.
So you don't have these big dents where the overlay goes over the top.
Okay.
Yeah,
so you got physical punch out, right?
Yeah.
Little tabs in the. And you can just push them out if you know how to make a...
Exactly.
Okay.
That's how we generally do it.
Excellent.
Yeah.
Nice. Yeah, I was very surprised. I did not expect this form factor and the stand and everything else. How much effort went into engineering the stand? Because I'm quite... it's the simple things that really impress me. Yep. And this, just the triple functionality of that, I think is really nice. I mentioned before... my first impression that probably the only thing that it needed was a hinge on here so that the handle can fold down. Was that even considered?
We did consider that, but simplicity is good.
Yeah.
But what we also considered was we had people walking around our labs with this, the angle of the handle, how the handle feels.
You're right, yeah.
With the weight, with and without the batteries in there.
Yep.
With the scope at 75 degrees and 90 degrees, and really just kept iterating. If you ever see our lab, there's a pile of just
random
version after version. Because getting all of these nuances right,
Yep.
even down to the alignment little tabs here.
Okay.
So that helps align the scope before you put the screws in.
Oh, no, okay. So that protrusion goes into the back.
Yeah,
if we take the battery off, there's a protrusion. And I really like...
So even there on the battery.
It is on the battery as well. So you can put the battery, if you take the hinge...
The kickstand comes off.
Oh, the kickstand. Oh, okay. Yes, it does. Screws off.
Yep. And then it goes straight onto here.
Right.
So you don't have to use the kickstand. You can use the main stand.
Got it.
And it's finding that balance. Again, it's not just, hey, let's build a stand, draw it up. Oh, that looks good.
Done.
It's how, when you feel, is it bashing against your leg?
Yep.
It's those intricacies. We
Nice.
just spend time, we literally have people walking up and down. It's kind of like a runway show up and down. How does it feel?
Yeah. Oh, that is great. I liked the attention to detail on the battery pack where there's a cover on there because there's a scope to battery interconnect that just plugs in, and you've got a cover plate on that, and you put a spare cutout in there just to store the cover plate, so you didn't lose, because otherwise you instantly lose the cover plate. It's just...
And it's these, that's where our team just puts it. It's that extra bit of thought, and that's hours sometimes about these little decisions, but it's the little decisions that you kind of remember and work.
That is really sweet. If that was an Apple product, I said that'd cost $1,000.
Maybe
the Apple stand.
The other thing is you found out on the bottom of it we have this material.
Yes. Yeah. It's really great. It's like a sticky.
It's the sort of material that you if you want to put your phone on your dash.
Yeah, right. It's the same thing.
It's the same sort of material.
Same material.
So it's a non-marking, but it gives you that robustness. Almost as if the scope weighs 5 times what it weighs. So it gives
Does that stuff where I can imagine like getting oils and stuff that'd like fingerprint oil that'd wear it like
water, just wipe it down.
Just wipe it down.
Yeah, just
okay,
wipe it down.
Right.
You see, it's picked up a bit of dust already.
Yeah. It's already picked up some stuff.
Just wipe it down.
Oh, very nice. Yeah, because the first thing I did when I took it out is I tried to push a button and the whole thing just moved backwards and you just went, peel it off. It came with a protective thing. And it
fresh off the factory.
Well. Yeah. Wow. Yeah, that is terrific. So the case doesn't come with it. Case is optional, but you're actually putting a lot of effort into it. Just the carry case and stuff.
So what we've just we've thought about people who are mobile. What do they want to use?
Yep.
How do they want to use it? So we've rather than having 10 little things to order. We thought the mobile users, you know, they want the bumper, they want a bit more protection just in case. They want the soft case to put it in, and then they maybe don't want this big bulky stand.
Yeah,
they want to
of
just
course.
put it somewhere simple. So what we do is we package it, we call it a soft case, or soft cover option. It has that, the soft case, and it comes with a kickstand. And you get all three things together.
Nice.
Again, you don't then, we're trying to think of how is the user going to use the scope. So it's how do we bundle things and make it that way.
Terrific. And the thing we haven't mentioned is, no, it does have the VESA mount on the battery pack as well,
Yes,
but
it
there's
does.
a VESA mount on the scope, and that's a big thing. So yeah, if you take this off, you've got the VESA mount on the battery pack, and also just on the back of the scope.
Exactly.
As well. That is really nice, because then you can use it for almost anything, any
Yeah.
form factor, any off the shelf.
I've seen one of our applications engineers, for example, she has a monitor, like a dual monitor stand.
Yeah.
One's a monitor, one's a scope.
One's a scope.
Because it's the same. It's the same. They used to be monitors. It's probably the same way you've mounted this TV onto the back of that.
It's just a VESA mount on the back, and yep.
So
Very
standard.
nice.
You know, then you can buy the accessories that work for you.
Yep, that's a complete no-brainer to put a VESA mount on the back. No video output though, but as we were playing around with before, because you've got your the tech. What's it called? The tech.
So what this has is it has a what we call a VNC, virtual network connection server in here.
Yep.
So you can hook this up to Ethernet, and then with a VNC client software, you can get really fast real-time updates.
We were doing that before. It was on probably 200 millisecond lag, 150 millisecond lag between dragging something on the screen and it updating on, or vice versa.
On my laptop.
It was on your and via the Wi-Fi, and it was really good.
And then with TVs like this, it probably has Bluetooth built in.
Right.
So then you can connect from your laptop to your TV, and suddenly,
You can cast from your phone. Maybe you could cast from your phone to your TV.
Yeah. So by simply having these easy connections, I've had it on my TV at home, 50 whatever inch TV at home, and I've had the shot on here. You can see it from across the house.
Right.
So
There was
easy to use.
Why didn't you build Wi-Fi into it?
So building Wi-Fi in requires a lot of regulatory testing.
Yep.
It's not an area that tech specializes in.
Right.
So we wanted to get it out to market. Some people don't even like Wi-Fi in Scopes products.
They go, oh god, it's got Wi-Fi.
Wi-Fi can cause problems in sensitive environments.
Right.
A lot of our scopes are used in environments where there's maybe RF measurements going on.
Got it.
So you're now putting a radiated source into the product.
Yep.
So that we start with a standard hardwired Ethernet connection.
How do you always pass EMC compliance first go with stuff like this? Do you have to reiterate? Okay, that's a sore point. All right.
It's not. It's a continuous improvement.
Continuous improvement. Yep. Okay.
EMC testing is we're lucky enough to have a full EMC group in the next building to us.
Nice.
Tech actually has. We've got all the chambers.
Yep.
So what this allows us to do is, we don't have to go and book an outside lab.
Got it.
Again, it's this attention to.
Can you do your own compliance testing in-house?
Yep.
So you certify yourself?
We self-certify for, I believe it's CE, but for the UL, you can't certify.
Oh, okay.
You can't self-certify for UL.
Okay.
Or CSA. So we work with the local houses there for that. But
Interesting.
they come in and audit us, so we're allowed to provide test data to them.
Got it.
But then they sign off, of course.
Got it. So, nice. That's very handy. Yep.
So again, having that ability, we're not taking one unit in and running it through a radiated test. We take a bunch of units in because we don't have that constraint that many people have of time in the chamber.
Yep.
So we just keep going and going, looking for those corner cases.
Fantastic. And manufacturing, where's this made?
So this one's going to be made in 2 locations.
Yep.
We're going to be making it in Shanghai, in our China facility, and we're also going to be making it in Singapore.
But it's your own facility in Shanghai, is it?
Yeah, it's our own facility in Shanghai.
Okay.
Yes.
Got it.
So that we've had a facility there for many years, and we've got such an awesome team there. Yep. They actually contribute to the whole process of the design. So when we put together on paper the first design, our manufacturing team are in there saying, nope, I can't. How am I going to get a screwdriver in there?
Right.
How am I going to assemble it, disassemble it? How am I going to make it reliable? Where's the pinch points for cabling? And so we go through this continuous process every time we do an iteration. our manufacturing teams get an input to make, you can design a product, but you have to be able to manufacture it.
Yes, I know,
reliably.
exactly. Yes, which is a big deal.
And then they run it through, just as many tests as we do.
Yep.
To get all the statistical data. They have their own. They even have their own facilities to run the units at elevated temperature, for example. So if we want to do a burn-in, but also, we take batches of units and stick them at elevated temperature for 48, 72 hours a week, if depending on what testing we're doing. We've got that facility in our Shanghai facility.
Fantastic. And what was there any thought given to going, oh, right, this is slim, it's almost like a tablet. Should we have the BNCs on the front or should we go on the side?
So we went BNC's front because of ease of use of access. Most people have got it. On a rack, it's then tricky to get in on the side. So,
and because it's also a bench scope.
Yes.
Because it's replacing. You can't replace the bench scope with a tablet scope. No. Nobody's going to buy that.
No.
Right? No one's
gonna. I've seen scopes before that have the connections coming out the top.
Yep.
And then where do the wires go?
Yeah.
In front of my screen.
Right.
So again, it's thinking about where the wires going to go when you actually plug in a probe. How are they going to lead out? How am I going to get into it when there's a rack?
Right.
The rack mount when we have a rack mount, the rack mount kit has slots so you can get cables around nicely.
Okay.
All those little features.
Nice. What about the cable on the side, the power cable on the side, 4-pin DIN?
Yep.
It comes out directly. Was there any thought about making it like a right angle and going back and having a cutout in the case that sort of made it the cable didn't sort of come out like this?
It's to do with the positioning of the internal components.
Okay, right.
Where we get the components there.
Oh, okay. So that's a right angle DIN on the straight on the PCB.
Straight onto.
Right.
We're trying to avoid as many.
Yeah.
Biggest point of failure in a design is often the interconnects and cabling. So it's how do we make sure we get the right cable? Reduce the number of cables.
Got it. And it's got a safety earth on the side, even though the supply is floating.
No, the supply is grounded.
The supply is grounded. Okay, so the plug pack supply is grounded.
Yeah,
okay.
but for users that are using it on a battery, you may still you should be grounding your scope. Floating scopes are never generally not a good idea.
Right. Okay.
So,
yes.
We know people do it.
Well, sometimes you have to do it for test reasons, but technically it's dangerous.
It is dangerous to do, and that's why you must have a ground log and you must keep it grounded.
Got it. No worries. So the plug pack, was there any thought given to making the main supply built in, or that was just from day one?
No, there was some thought in there. Yeah,
right.
We did look at doing that.
Okay, but it was like space, and then the triple functionality or something you wanted, it just didn't work.
Combination of space, keeping noise down.
Okay.
Putting a switcher on the main board.
Oh yeah, of course.
So we decided in the end to go with the external power supply.
Right. Okay. Yeah. Well, it ultimately makes sense because you would have had it. I don't know. Yeah. What is it? 60 watts or something?
65, I think it's 24 volts.
Yeah. Probably. That's max. Probably operational. It's probably 20 or 30 watts or something.
We need enough power from there, of course, to not only run the scope but charge the batteries.
Yes.
So
exactly.
It's finding that balance point.
Oh no! Wait, you have 4 hours on a single battery, and that's 98 watt hours.
98 watt hours.
Okay.
So,
right. So
you can charge it in. Of course, you can charge it in here, but we also have an external battery charger.
Oh, okay.
So if people want to.
Right. Okay.
You can literally have a row of chargers and keep going.
Nice. Yeah. And we were mentioning before, and you said you think it might have it, is that it has technically circuitry inside to, like, if you physically turn off channels, 2, 3, and 4, you can power down the power supplies for those sections to save battery. You said it might have...
I think it has. I know there was discussion of that at one point.
Right, okay. Whether or not it's in there, we'll find out in the teardown. All right.
As anybody that's worked in a remote environment, you lose contact with these sort of little conversations.
Yeah. Oh, there's thousands of them.
Yeah, and we have a product planner who works for me, and he's always working from the marketing team and understanding customer, feeding that into engineering, and engineering is always an evolving design.
Got it.
How do we solve problems?
How big is the design team? I know it's bigger because you've got user interface software people. Because we're sort of EEVblog's kind of more hardware focused, like the hardware team, the actual.
If you include
electronics hardware,
the number of hardware people is probably just actual hardware design people is maybe 3.
Okay, right. Yeah, small team.
But then you've got a team of FPGA engineers.
Yeah, there'd be a whole team of FPGAs.
Some people classify them as hardware. Some I think of them as hardware.
Yeah. I would think of them as hardware as well.
What we do is we flex a team depending on, sometimes you need to run a lot of engineers at one time to to get through certain features.
Yep.
And then maybe at the beginning or the end you've got an architect at the beginning. At the end you're just answering questions from the software team.
Got it.
But we would go up to maybe 7 or 8 at times
Okay.
on that. We've got a great system for working through the design, checking all the bits of the design as they're done, checking them into our systems there,
Yep.
filing bugs, and then just continuing that to reiterate that.
And then you'd have an ASIC team as well that worked on the ASIC.
Yeah, that's a separate team. They haven't worked on this ASIC. They're working on other ASICs.
Right.
There's a continuous. We have always have an ASIC team.
Right.
And then we have a software team that's again flexes depending on any given month what the areas of focus are. So that probably can run as high as maybe 25, 30 people.
Oh, okay.
So,
serious. Yeah.
And not all of them are writing lines of code.
Yeah.
A number of them are doing software quality.
Software test benching.
Yeah.
You'd have a couple of people working on test benches.
Exactly. So it's this continuous, looking at, checking in the software, reviewing the software,
Yep.
looking for bugs, filing, because it's a lot easier. We build the new software on a daily basis.
Right.
It's a lot easier to find the bug 24 hours after it was created,
Yes.
rather than about a week later.
Yeah. Yep.
So
Been there.
We've got a great team for that.
Got it. And what was I going to say? So it comes standard with Ethernet, LAN, all that sort of stuff. How do you decide which stuff you're going to bundle? Like a serial. Are we going to bundle serial triggering? Are we not? Are we going to bundle this and that?
So
How does that work?
what we look at is what people need.
Right.
So not everybody needs serial decode.
Yep.
So why build that into the cost pricing of the product? Same with the MSO capability. Same with the function generator.
Right. Yeah. Okay.
We talk to customers. I want a separate separate signal generator.
Yes.
I'm not going to use it.
Yeah.
So it is. How do we? We look at the market. It's a market decision as well as what features can we put in, and how do we turn those on and calibrate them, and how do we make them accessible to customers? What we're trying to do is not have features that have to go back to this factory.
Right.
Once you bought it, you never need apart from having it calibration done.
Right. Over. Yeah. Of
That's
course.
the only time to ever come back.
Okay.
Upgrade the bandwidth, add a feature. It's all software now.
And there's not huge hardware cost in a function gen really, and digital inputs aren't hugely costly and stuff like that.
We build some of those features. It's finding that balance between having separate models, because if you have separate models, then you have to have separate builds, and then if the customer, for example, has a model that has to either come back to the factory for serial digital channels, or they can't even upgrade it. And that's suddenly what their design needs. You buy a scope today, you buy it maybe for your design. 2 years time, you might be working on something completely different.
Yes, exactly.
So having that upgradability in the field, easy to do.
Got it.
And don't need to send it back. The hardware's in there, and it's finding that balance. How do we decide which features to do?
Got it. And from the FPGA side of things, was there any thought given to turning that into a custom ASIC and making it potentially faster and cheaper, or was that?
We looked at very many options, from custom ASICs to eASICs.
Okay.
To FPGA, and the FPGA gives us that flexibility.
Yep.
Right.
There's field upgradability. Yep.
If a new serial standard comes out, and we want to do that.
Right.
We don't want to be. We want that flexibility in the product. So it's finding that sweet spot between balancing hardware performance, power consumption.
Yep.
And with upgradability.
Got it.
And flexibility.
Explain the eASICs for those who aren't familiar.
Yeah. So an eASIC is where you will take a FPGA design and basically just directly from that FPGA design create a custom, a hard-coded FPGA.
Hard-coded FPGA rather than, you take the VHDL or Verilog. Do you use VHDL or Verilog?
I think it's Verilog, but I don't quote me.
Okay, no worries.
So I'd have to not 100% sure on that one. Yeah.
All right. So whereas a fully custom ASIC, you'd take The Verilog and the silicon would be very different. It'd be lower. So the ASIC probably gives you equivalent power consumption to the FPGA. You don't gain any advantage there, but it would be cheaper masking.
In the end, it comes out with a lower cost component, but as you say, you don't get the power savings as much.
Yep.
And so then really you'd want to go to a full-blown ASIC.
Right.
And it's finding that balance. You know, we want to make sure that, you know, in 2 or 3 years' time, this is still a flexible platform and a flexible product for our customers.
Got it. No worries. Well, this is very, very nice. I was very surprised. Do you think any other competitors are working on a similar sort of modular battery thing?
We've got the best engineering team.
Right. Slightly biased. Slightly biased.
I'm slightly biased.
Okay.
Of course I am.
Slightly biased.
I can't say enough how proud I am of our engineering team on this one.
It's very impressive. I was not expecting a modular system like this. Although I can now understand how you talked about the tactile buttons and everything. I'm still not on board with it. As I mentioned, I think you've got 3 different color blacks here.
As I said, qualification build.
Qualification build. It may not be final.
Yeah.
Okay. All right. Maybe I'm too picky. I don't know.
No, can't be picky enough.
Right.
I appreciate it all.
Yep.
Always looking for feedback.
Terrific. Well, I'll have no doubt feedback. I mean, I've just gotten this, so we had to turn it on before we took it apart. Sorry, but that's pretty impressive. So there's no fan in the battery compartment.
Nope.
No, right. It's just in the scope itself. Sweet, and it charges from the existing plug pack. It charges interval.
Nice. If you want a faster charger or to have a bank of batteries,
you can do that. Yeah. Okay, they'll sell you one, I'm sure.
Always happy.
Right. So So you had a target price in mind. Was that based on the existing models, like under 2,000? I think you said.
Yeah. So we want to make sure that this is a scope that's affordable for people looking for this level of performance.
Right. Got it. Okay. I think you've done the business.
Great, man.
Yeah.
Happy to hear the feedback.
Awesome. Well, thank you very much.
Thanks very much. Really
Excellent.
appreciate everything.
And you're on a plane in leaving in 20 minutes.
Yeah, and off for our next stop on our journey around Australia.
Yep.
Thank you.
Oh, no, I forgot about component shortages. Component shortages. How everyone wants to ask about component shortages. How has that affected tech much? It's affected everyone.
It has an impact. You can see it.
Right.
You can see it on so if you go to partners' websites and see it on later.
Right.
But we've got a great operations team. You know, we're fortunate enough to be part of an organisation called Fortive, which gives us more leverage to get parts.
Okay, right.
We leverage them, and it's been.
You can share them across the partner companies, maybe.
It's more about just general leverage. Yeah. You know, we've got a team there who works on the commercial side as well. So that has been very useful for us.
Yep.
And we've got operations team that are just working night and day. You know, one thing if we find alternative components, we don't just put them on board and ship them.
We talked about this yesterday. It was like you can't just buy them at the Shenzhen. We found some 100N caps at the Shenzhen market. Let's whack them in. It's just a 100N cap, right? It has to be qualified.
So that 100N cap will go into a product, and that product then goes, as you asked about EMC testing.
Yep.
It goes back through.
Yeah, right.
You don't change your component without.
Yes,
you go through everything. So
because you can do that in-house, that's a bit easier, but still. I mean, I assume you've got a couple of engineers just working on component qualification.
That's right. We're
finding alternative components in the current crisis.
We have a component engineering team that does this on a daily basis.
Right.
Even prior to shortages. You always get last time buy notifications.
Yes. The last time buy. Yep.
So we've always got a team working on that, and that teams working kind of double duty with regular last time buys and shortages. They then go, that they interface with our engineering team.
Right.
Is this a good alternative? We then work with we've actually got our own ability to board build factory in Beaverton. We can actually build boards if necessary. Yeah.
Wow.
So again, we can leverage that if needed to do full board builds. This isn't just necessarily changing a couple of components.
Right.
Hand
do you normally put production items through that?
Yeah, we do. We leave that mostly for our higher end products.
Oh, okay, right.
So there's high count BGA devices, specialized devices, devices that have to maybe be built in the US, for example.
Those and those low volume builds, there's only so many $100,000 scopes you're going to sell a year.
Exactly.
Interesting. Well, thank you very much.
Appreciate it.
Yep.
Thanks for your time.
So you'll see this in June.
Thanks.
So I'm going to hang on to this for a couple of months.
Yeah, I know.
Can I do teasers?
Oh,
No,
please.
all right.
Thank you.
Catch you next time.
Thank you.
That's awesome.
Oh.
That was great.